in the next example, the book asks for the following. It says, what are the xi's, okay, the delta xi's, and the k values, so the ki's, for this particular function. And so where do these things come from? Well, what they're saying is the following. They're saying that the xi's are the endpoints of the interval. Okay, so the first xi. Okay, so start at 0. This guy is x0. This guy is x1. This guy is x2, and this guy is x3. So our xi's, well, x0 is equal to 2. x1 is equal to 2.5. x2 is equal to 3.5 right here. And x3, which we got up here, is equal to 4. Our delta x's, well, the first delta x, our first change in x, okay, so we're going to call this delta x1. That is equal to x1 minus x0. Okay, so in general, our delta xi's, that's equal to xi minus xi minus 1, like that. All it says is, so for delta x1, this right here, this length is delta x1, and the length of it is given by x1, which is 2.5, minus x0, which is 2, so that is just 0.5. Okay. Now the next delta x, that's delta x2, the next change in x is equal to x2 minus x1. Well, that's x2 over here at 3.5. Okay. So 3.5 minus x1 over here at 2.5. So that's equal to 1. So that means delta x2, I should put delta x1, I don't know why I put delta xi. Delta x2 is equal to a length of 1. And now delta x3 is equal to x3 minus x2, just like that. Okay, and so this is going to be 4 minus 3.5. I'm just getting these numbers from here. So that is 0.5. So delta x3, 0.5. It's just the length of these lines, right? Okay, so now our ki's. Well, ki is the height on the interval. That's our height on our interval delta xi. So for example, we'll do it over here. Actually, I'll do it right here. K1 is equal to the height of the interval, the height on the interval. Now, on the interval containing this guy, I should say, because delta xi is actually a distance, so I should say on the interval containing x, I shouldn't even say that it's containing, because it doesn't necessarily have to be containing it. Containing some x star, which is an element of, let's go xi minus xi minus 1. Okay, so basically, look, the k values is the height of this guy. Okay, so k1, big picture is K1 is the height of this guy, which is 1. K2 is the height of this line, which is 3. And K3 is the height of this line, which is 2. So now what it says is if we want the areas, if we want the total areas, I should have dotted this one too. Keep it consistent. If we want these total areas, this guy, okay, and this guy right here, if we want the sum of those areas, what we're going to do is we're going to add up how long they are, which is delta xi, and usually people write that in the back. So I'll write in the back how long they are times how high they are. So how high they are is ki, how long they are is delta xi. So this right here gives me the area for each of the rectangles. Now we have to know where to start from. Well, our i's have to start at 1, and they have to end at 3. Now it makes sense here. Go from 1 to 3, go from 1 to 3. So watch. This right here, when I plug 1 in, I get K1 times delta x1. And then I'm going to add to that when I plug in 2 here. When I plug in 2, I get K2 delta x2. And when I plug in 3, I get K3 delta x3, the change in the x. So these areas are each given to me by K1, which is 1. Delta x1 is 0.5. And then we're going to add to that K2, which is at a height of 3. Get that from right over here if I want. And is delta x is 1. And then we'll add to that K3. Okay, its height is 2. And its delta x value is also 0.5. So when I do the math out here, and I add those guys together, I end up with a value of 4.5. So the total area underneath the step function between the x-axis and the step function is 4.5 square units, whatever that happens. So I'll just write that square units, whatever that unit happens to be.